Hey, boys and girls, today we're going to be talking about probably the trickiest topic that you will have, okay, our whole year, and that's dividing fractions. So listen very carefully. This video may be a little bit longer than most because I want to make sure we understand. The first thing I want to talk about real quick is if I took, and this is like my go-to example, if I said, let me think about this for a second, how I wanted to word it. 24 divided by 6. All right, 24 divided by 6. Hopefully, most of you have already come up with the answer in your head. We know that answer is 4. Okay? So, and that division is kind of easy. But when we start talking about division of a fraction, it gets a little complicated. So what we want to do is try to make it easier. All right? And we can take this division problem here and well, I don't know. Multiplying is always easier than dividing, always. Okay, hopefully that you realize that we can multiply numbers easier than we can divide them. So if I said 24 times the reciprocal of 6, now we learned what reciprocal was in a prior video. The reciprocal of 6 is 1/6. If I said we can get the same answer by multiplying, then that would be easier. And it may not, you may not think this is easier because you're like, Mr. Bell, I know what 24 divided by 6 is. And that's great. But when we start getting into fractions, you may not know what 3/8 divided by 5/12 is. Okay. So we can multiply instead and get the same answer. And that's what I'm trying to get at. So we can use this reciprocal. We can use the reciprocal of 6 and just multiply instead and come up with the same answer. So that's the goal here. That's what I'm trying to get at. So in order to multiply a whole number times a fraction, we've already learned this, I have to turn that whole number into a fraction by putting it over 1. All right. Now I just multiply top times the top, bottom times the bottom. 24 times 1 is 24. 1 times 6 is 6. Now I have an improper fraction. I have to simplify it. So I say 24 divided by 6. Remember, the top number always goes inside the house. Bottom number always goes on the outside. 6 divided by 24 is 4. I subtract. I have no remainder, so my answer is 4, which is the exact same answer we got before. Okay, so that's the idea behind this. That's how this works, and that's what I'm going to show you some examples of really, really quick. Or at least I'm going to try to be really quick. That's not what I want. I like this app, but I don't, because it always does that. It leaves stuff on the board. All right, but maybe that'll show you, that'll keep you there as an example. Okay, so because it's done as layering. I don't know. I don't get all that layering crap. All right, anyway, let's look at our first example. We have 3/7 divided by 3. Okay, now there's an acronym that I've used in the past, and if any math teachers are there and you're math purists and you're like, oh, we can't use this acronym, hey, anything that helps somebody remember, this helps. Okay, I didn't learn it this way, or did I? Maybe I did. I don't remember. But it is KCF. All right, I want to keep the first fraction the same. That means I don't want to change it. I want to change from a division problem to a multiplication problem, and I want to flip the second fraction. All right, so keep, change, flip. And I do it in that order. Okay, so here's my example. 3/7 I'm going to keep. I'm going to change to a multiplication problem. I'm going to flip the second fraction. When I say flip, I mean use the reciprocal. Reciprocal. I'm using the reciprocal. All right. So the reciprocal of 3, we learned in a prior video, is 1/3. Now I can just multiply. Well, let's just say this. First, I want to see if I can simplify. Okay. I can't simplify the 3 and the 7. I can't simplify the 1 and the 3, but I can totally simplify the 3 with the 3. All right. I can divide both of those by 3. And that'll help me with a smaller answer. So 3 divided by 3 is 1. Keep the 7. 1 is the same. 3 divided by 3 is 1. So now I say 1 times 1, 7 times 1, and that's my answer. Okay, so 3/7 divided by 3 is 1/7. Okay, that's it. That's all you have to do. I'm going to show you a couple more examples of different kind of problems, but essentially they're all like this. Okay, we're always going to do that reciprocal deal. All right, you're always going to do that when you're dividing fractions. Always going to use a reciprocal. All right, next example I have is 5/9 divided by 1/8. All right, so employing the keep, change, flip idea, I'm going to keep this first fraction, 5/9. I'm going to change it to a multiplication problem, and I'm going to flip this second fraction. All right, see if I can simplify, which I can't. So I just have to multiply. 5 times 8 is 40. 9 times 1 is 9. This is an improper fraction, so I have to simplify that. All right, I divide 40 by 9. 9 will go into 40 4 times, 36. And I have 4 left over, so it's 4 over. Remember, I got to go back over my original divisor. 4 and 4/9. Let's see if I can erase this. 4 and 4/9 is my answer. And that is my final answer for that one. Okay, super easy. Super easy. Let's see. Next example, I have, we'll say 12/5 divided by 4/5. Going to use this same rule here. Keep, change, flip. Keep the first fraction, 12/5. Change to a multiplication problem. Flip the second fraction. All right. Now look to see if I can simplify. Bingo, I can simplify the 12 and the 4. Oh man, Mr. Bell, I can also simplify the 5 with the 5. So that's what I'm going to do. What the greatest common factor between 12 and 4 is 4. So I divide by 4, divide by 4. The greatest common factor of 5 and 5 is 5. So I divide both of those by 5, and I just rewrite it. 12 divided by 4 is 3. 5 divided by 5 is 1, times 5 divided by 5 is 1, and 4 divided by 4 is 1. See how much easier this looks than some other problem that we could potentially have? All right, 3 times 1 is 3. 1 times 1 is 1. And I don't want to write off the board here, but my final answer would be just 3. All right, so this fraction, let me show you this. I'm going to kind of point. This fraction here would be so much more difficult to simplify if I would not have simplified beforehand. All right, and I'll show you why. If I multiplied 12 times 5, I would have got 60. If I'd have multiplied 5 times 4, I'd have got 20. Okay, so now I can look at that and say, oh, look, I can simplify that by dividing both the top and the bottom by 10, which leaves me 6 and 2. And then I can simplify that as well by dividing both the top and the bottom by 2. All right, 6 divided by 2 is 3. 2 divided by 2 is 1. Yes, I do wind up with the same answer, but still, you get my point. This is kind of a big number to start with, okay? So we don't necessarily want to do that. Let's erase that, and oh, shucks. Okay, let's kind of stick this other one right in the middle. Last one. 5/9 divided by 2/13. Okay, 5/9 divided by 2/13. Still using keep, change, flip. So I keep the first fraction, 5/9. I change to a multiplication problem. I flip the second fraction. All right, look to see if I can simplify. I can't simplify the 5 and the 9. Can't simplify the 13 and the 2. I can't simplify the 5 and the 2, and I can't simplify the 9 and the 13. So I just, whatever my answer is going to be, more than likely it's going to be simplified. Now, it may be improper because the top may be bigger than the bottom, and I'll have to figure that out. But the answer itself will be simplified. 5 times 13 is 65. 9 times 2 is 18. Yeah, that's not exactly easy to deal with, okay? So I know, at least I think I know, that 18 will go into 65 3 times, because I think 3 times 18 is like 54 maybe. 54. All right, so I subtract 54 from 65, and that is what, 9? Oh, it is going to simplify. How about that? 9/18. Okay, 3 and 9/18. So I can simplify that to 3.5. I sure hope I did that right, because that looks like a great answer, 3.5. All right, but keep in mind, we got to follow this rule. Keep, change, flip. Keep, change, flip. Keep, change, flip. Keep the first fraction, change the second, or change the operation to multiplication, and then flip the second fraction, and then just multiply like you have been multiplying. Okay? Nothing new, nothing new. You can totally do this.